Know that directional control valves work by shifting an internal movable part. We will refer to this movable part as a spool, though it could be a poppet or a disc as well. This movable spool opens or closes various passages or ports in the valve. In this lesson, we are going to take a look at different kinds of directional control valves, and we will discuss various techniques used to shift the spool. In addition, we will look at a special kind of directional control valve that controls direction and flow rate at the same time. Let's begin by looking at directional control valves found in many industrial systems. These valves are designated as two-way, three-way, or four-way valves, depending on the number of ports they have. A two-way directional control valve is generally used to connect or isolate parts of hydraulic systems. With the spool in one position, the valve passage is blocked and fluid cannot pass. When the spool is shifted to the other position, the passage is opened and the valve becomes passing. Occasionally, three-way directional control valves are used. These valves have three ports, one going to pump, another to tank, and the third to an actuator. In most cases, when a three-way valve is required, a four-way valve is used and one of its ports will be plugged. The most commonly used directional control valve is the four-way valve. Its four ports can be interconnected in various ways, depending on the type of spool used inside the valve. Notice that all the ports on this directional control valve are located on the bottom of the valve. This is done to make servicing and installation easier and more efficient. The body of the valve is bolted to a precision-made subplate, and the system piping is connected to the subplate. If the valve must be removed for service, it is simply unbolted from the subplate. The lines don't have to be disturbed. Combinations of subplates called manifolds are sometimes used when several valves are mounted side by side. This reduces space requirements and allows several valves to be controlled from a single compact operator station. Some directional control valves only have two positions. The spool can be shifted to one extreme end of its travel or to the other. For example, this four-way directional control valve opens a passage from the pump to port A and from port B to the tank when the spool is shifted all the way in this direction. And it opens a passage from the pump to port B and from port A to the tank when the spool is shifted all the way in the other direction. However, many valves have a third or middle position. What they do in this middle position, or center condition as it's called, depends on the kind of spool that is used. While many different spools are available, the four most common are the open center, closed center, tandem center, and float center. Let's start with the open center spool. Centering the spool connects all the passages together. Flow returns to tank at a low pressure, and the actuator is free to move in either direction. However, once an open-centered spool is centered, other actuators in the same system will not operate because system flow is being returned to tank. A closed center spool, on the other hand, blocks all four ports when the spool is centered. This permits actuators to operate independently of each other, and it also allows cylinders to be stopped in mid-stroke. However, a cylinder rod stopped by a closed center spool will gradually drift out if the valve is left in its center condition for more than 2 or 3 minutes. This happens because fluid leaks past the spool, building up pressure at both ends of the cylinder. Since the cap side of the piston has more area exposed to pressure than the rod side, the rod creeps out. A closed center spool also requires the system to generate a lot of heat, even when no work is being done. As long as the spool remains centered, flow from pump to tank is blocked, so pressure continues to rise until the relief valve is forced open. A tandem center spool can stop cylinders in mid-stroke and reduce power consumption by dumping the pump directly back to tank. This is possible because a passage drilled through the spool connects the pump to tank. However, the passage does restrict flow and raise pressure. So if several tandem valves are operated in series, the cumulative effect may force a system to produce a lot of heat even while idling. The fourth center condition is the float center or motor spool. It connects both sides of the cylinder or motor to tank, allowing the actuator to float or move freely whenever the valve is centered. If the actuator must be stopped for some reason, a pilot-operated check valve can be used. In this example, the cylinder will not continue to stroke until pressure on the A side of the cylinder rises high enough to unseat the check valve. Centering a float spool also blocks the pump passage. This means several different actuators can be operated from the same power source because full pump flow and pressure are diverted elsewhere in the system when any one spool is centered. Now, even when a four-way directional control valve has only two positions, it may still have what's called a crossover condition, and it may affect the operation of the system. In this symbol, the dotted lines indicate that although the valve has only two positions, there is a third position for an instant as the spool shifts from one end of its travel to the other. In this example, the spool has a closed center crossover condition. During a shift from one extreme position to the other, pressure will drop very little. In some applications, however, a slight drop in pressure may be desirable. For example, if a heavy load must be reversed, an open center crossover condition may be used to minimize shock as the spool shifts. Now, we've seen what happens when valve spools are shifted, but we also need to understand how they are shifted. All directional control valves require an external force to shift the spool. The force comes from the valve actuator, which may be manual, mechanical, hydraulic, pneumatic, or electric. Manual actuation is simply when human energy pushes a button, shifts a lever, or steps on a foot pedal. Manual actuation is used on things like fork trucks, which require an operator to direct the movement or to sequence the operation. Mechanical actuation is usually accomplished with a cam, which is simply a valve with a roller or ball on the end of an extension of the spool. The roller or ball contacts some part of a machine member, like this cylinder rod extension, which moves it in and out. Mechanical actuation is commonly used when valve shifting must occur as the machine reaches a specific position. Either air pressure, pneumatics, or fluid pressure, hydraulics, may also be used to move the spool. Usually, a separate, smaller valve provides the pneumatic or hydraulic pressure used to actuate the larger valve. This is called pilot operation. Shifting the spool can also be done electrically with solenoids. Solenoids are electromechanical devices which convert electrical energy into linear mechanical energy.